This is our lesson on 6.4. This is the second part. In this triangle, they're telling you that segment AB is congruent to segment BC. So that makes this triangle isosceles. So we have an isosceles triangle theorem, remember, that tells you if these sides are congruent, you should know where the congruent legs or the congruent base angles are. These are the congruent legs. Those are segments. This is a base, which is also a segment. These two angles would then be base angles, and those are the ones that are the same. So if you know one base angle is 50, then the other base angle is 50. Now 50 and 50, that gives you 100 degrees. And we know there's 180 degrees in a triangle. I'm just writing this out just so you can see the work. A lot of this work can be done in your head though. 180 degrees total minus the 100 degrees that you have gives you 80 degrees left over for your vertex angle. So this is an isosceles triangle. It's also acute because all the angles are less than 90. Here's another example. Segment NL is congruent to segment ML. That makes this triangle isosceles. This is your vertex angle because it lives in between the congruent sides, which makes these angles base angles. So even though they're marked differently, they actually are the same. That's A degrees, that's B degrees. A and B are the same exact value, just so you know. So if you have 180 degrees total and your vertex angle is 40 degrees, that leaves you with 140 degrees. And both of these are the same. So you take that 140 and you split it equally. So again, this isn't high level math. This is stuff you can do in your head. I'm just writing it out so you can see it and hopefully realize that it is that easy. These two base angles are both 70 degrees. This is a little different problem. Notice how there are three triangles in this problem. There's a big triangle, and then there's two smaller triangles inside of it. And they're telling you that segment QT is congruent to segment RT, which makes this little triangle isosceles. Also, segment RT is congruent to segment RS. That makes this triangle isosceles. So we'll start with this triangle right here. These are the legs. That's your vertex angle. These are your base angles. That angle is 56. This angle is 56. Now 56 and 56 gives you 112. So if you take that away from 180, that's going to tell you what's left over for your vertex angle. So that'll give you 68. Now this angle over here that's beside the 56 degree angle, that's actually the vertex angle for the other isosceles triangle. And you might not know what it is right now, but you should in a second. Because notice how this 56 degree angle is part of a linear pair. So what's left over? You need 180 degrees in a straight angle. If you take away 56, you get 124. That's the vertex angle for your other isosceles triangle. Now, we don't have to do the same math again. We're going to take 124 away from 180 because there's 180 degrees in every triangle. We already did that. We know it's 56. So these two angles here, they're the same because they're base angles of that other isosceles triangle. And they add up to 56 degrees. Remember that triangle exterior angle theorem? This is an exterior angle. These two angles add up to give you that angle every time. 56 divided by 2 will give you the measure of those two angles since they're the same. So that would be 28 degrees for both.